Recording in progress.
Okay. And yeah, for this week, we're just gonna start going. We have a lot to go over this week. This week, we're gonna start with basic algebra now. So when you've been throughout math, what you guys do is you guys work with equations, anything like 5. Let's see. And generally, when you're younger, you'd represent this with a question mark. But now we're going to change that, and we're going to start representing unknown values of variables like x. And in this case, to find x, we would just solve this equation. So in this case, x just replaces a question mark. And that's essentially what x is. So say if I had and we want to just think about this like as a question mark, or if this is any number, we just don't know what it is yet. So we also want to treat it like a number. And to find out what x equals, we want to make sure x is alone. So if we subtract 3 from both sides, you're left with x and what x is equivalent to. So with linear equations, when you're trying to solve for x, you want to just move everything to one side and have x alone. Just if I were to do something like okay, so if we had something like this, again, to solve for x, we want to have x on one side of the equation and all the numbers on the other. So first, what we treat x exactly as a number. So when we have something like 2x plus 3, would still multiply through, so 2 times x. And when we have 2 times x, we always just represent it as a number, x. So this would just be considered 2x. So we have 2x, and then 2 times 3, 6. And now we want all the x's on one side and all the numbers on the other. So if we subtract 2x from each side, because we can do that, because 2x is just a number, we're left with 6 equals 3x plus 1. And then we want to remove this 1. So we have 5 equals 3x. And then to solve for x, we can divide both sides by 3. So this is how you solve equations with a single variable. Are there any questions with this? Does everyone understand what the concept of x? Because this is very, very important. Everything else today is going to be built off this concept of you understanding x is a variable. It can be any number. Okay, no questions. Let's move on. Let's try a few single variable equations. I want you guys to try to solve. So I want you guys to try to solve these 3 to just see if you have the concept down. I'll give you guys 5 minutes. Are you guys able to see the numbers I've written down?
Yes.
Just waiting on a few more people to answer. Okay, so let's get to it. So for the first one, like we said, we want to move all the numbers to one side first. So we want to subtract 3 from both sides. So we are left with only x on this side. So we'd have 2x equals 8. But we don't want to know what 2x is. We want to know what x is. So we can divide both sides by 2. Get x equals 4. You need to remember, whatever you do to one side of the equation, you must do the exact same thing to the other side. So for this one, we want to isolate x on this side again. So we want to add 2 to each side to remove the -2 over here. So we get 5x equals 14. And then we want to know what 1x is. So we divide by 5. And then this is equal . And now onto the last one. So we have x on both sides this time, but we want x only on one side. So what we can do is we can subtract x from both
How
sides
does
to
the
remove.
minus become the plus? Like, because there's 5x minus 2 equals 12.
We add 2 to each side. Because if we add 2 here and we add 2 here, they're still the same. They're still equal to each other. But -2 plus 2 equals to 0. So we have 5x, because this becomes 0. But we added 2 over here, so we must add 2 over here. So this becomes 14. You got it?
Yeah.
Now onto this one. We want to make sure there's only x on one side, so we want to find the smallest one, subtract by x. So let's subtract by x on both sides. We're left with 3x plus 3 is equal to -9. Again, we want to make sure x is alone. So we do 3x plus 3. Now we have to subtract 3, but then we have to subtract 3 from this side also. So we're left with 3x equals -12. And then to get x by itself, we divide by 3. X is -4. And then if you're ever uncertain about your answer, you can always check it. So for this one, we have x equals 4. You can substitute it in. You have 2x, which is 2 times 4 plus 3. And I'll check if this statement is true. You get 8 plus 3 is 11. So the first one's correct. For the second one, we have 5 times 14 over 5 minus 2 equals 12. This equals 14 minus 2, which is equal to 12. So that one's also correct. Now let's check the last one. 4x plus 3 is equal to x minus 9. X is -4, so 4 times -4 plus 3 is equal to -4 minus 9. So -16 plus 3 is equal to -13, which is true. So every time you do a question and you're uncertain, you can always insert x back into the equation to see if you're correct. So, are there any questions about solving equations with only one variable? Okay, no questions. Let's move on. Now let's talk about inequalities. So we're going to take, so we all know what inequalities like these symbols, greater than or less than, depends which way it's facing. This is less than, greater than. So these are the big five. So, and remember, the open mouth always points to the bigger number. So you want this side always to be larger than the one over this on this side. So instead of doing like 7 is greater than 5, now we're going to insert variables. Now say if we had 2x plus 3 is greater than 11, like what we had before. We can solve this the same way. What we do to this side, we do to this side, 2x. We subtract 3 from both sides. Now we have 2x is greater than 8, and x is greater than 4. So what this means is for any number greater than 4, this is true. And we can express this on a number line. If this is 0, 1, 2, 3, 4, 5. So we look at it. So it has to be greater than 4. So we use an open dot. This is something you want to know. Open dot on a number means not included. But a shaded dot means it's included. So we take an open dot, and now we have to draw a ray in the direction. So what this says is any number greater than 4, but not including 4, is a solution to this equation. So we can solve these in the exact same ways we'd solve the other ones, except when we're multiplying by negative numbers. Like for a basic example, -5 is greater than 5. Say we multiply by -1 on both sides. We have x is greater than -5, and we know x is 0 is true because 0 is greater than -5. So if we input 0 into our initial equation, we get -0, which is just 0 is greater than 5. But that's not true. So something went wrong here. So this is the exception with inequalities that makes them different from equations. If I have -x is greater than 5, whenever you multiply or divide by a negative number, you have to flip this. So even if it's like greater than or equal to, if I multiply by -1 or divide by any negative number, this sign flips directions. Now you have x is less than or equal to -5. So if we try like -6, now we see that this is greater than 5 because 6 is larger than 5. So the one exception that makes inequalities different from those equations is when you multiply by a negative number, this sign flips. So let's try a few. And for your graphing this one, you have to shade in the dot because it's greater than or equal to. So whenever there's a line, you shade in the dot. So I'm going to have try a few practice questions with this concept. And I want you to write an inequality for this line. Okay, so do these three. If you can't see this, this is a 9. This is a slightly longer question, so I'll give you guys a few more minutes. And when you answer, I want it to be fully simplified. So I want x, not x multiplied by any number. Okay, it's been a bit, and let's just work on these. There weren't that many answers for them. So did you guys just not, was it not enough time to finish, or you just not understand the concept? Okay, no answer. So let's just start with the first one of the same techniques we've been working on. 5x minus 9 is greater than or equal to 11. We want to isolate the 5x, so we add 9 to each side. So we have 5x is greater than or equal to 20. But we don't want 5x, we want x alone. So we divide both sides by 5. X is greater than or equal to 4. On to the next one. Negative 2x plus 3 is greater than, is less than 9. We want x by itself. So we subtract 3 from both sides. So we have negative 2x is less than 6. We want to divide by negative 2, but because we're dividing by a negative number, this sign flips. So we have x is greater than negative 3. What you could also have done is divided by 2. I forgot to flip my sign. Okay. Ignore this. divided by 2. Negative x is less than 3, multiplied by negative 1. X is greater than 3. Wait, nope, that's a negative. So x is greater than negative 3 on this because we multiply both sides by negative 1. And then the sign flips. So let me just do that one again. So we're left with a negative 2x. We can divide both sides by 2. Multiply both sides by negative 1. But then there's a sign flip. X is greater than negative 3. Is it cut off? There. And for the last one, we have open dot, which means it's less than or greater than. There's no equal to. And then we see it's 8. So what we see is x is less than 8. Because we see the point is 8 and it's going to the left. So that's our inequality. Are there any questions of inequalities? Because then we're going to start going over to 2 variables. Okay, no questions? Let's start with 2 variables. So now we're going to introduce something new. The concept of y. So now you're going to see equations like this. Where x and y can be anything you want it to be. So technically there are infinite number of solutions to this. So say if we wanted x to equal 1, y would equal 5. Say if we wanted x to equal 2, y would equal 7. So how can we express this with a graph? And we can plot points one by one. So if x equals 0, y equals 3. Oh, this is 3. This is 0. If x equals 1, y equals 5. So this mark is 5. If x equals 2, y equals 7. If x equals negative 1, y equals 1. And then we can see there's a trend. And this equation forms a line. And this line represents all possible solutions to this equation. So any point on this line, the x and y coordinates of this will be a solution. And this, the form you see here is called, it's the slope-intercept form. So let's first define what slope is. So if we have a line, call this 0, 0. Actually call this 1, 2. Call this 5, 6. Slope just measures how steep the line is. If a slope is positive, it will always face this direction. If the slope at a point is negative, it will go this direction. And the larger the slope, the steeper the line. So this would be a large slope, which means the slope would be large. But if we have a shallow line like this, it's a smaller slope. So to find slope, the real equation is m equals y2 minus y1 over x2 minus x1. This is really just a very fancy way of saying slope is equal to the y coordinate of the second point minus the y coordinate of the first point divided by the x coordinate of the second point minus the x coordinate of the first point. And it doesn't even matter which point we choose as our first or second point. So say we wanted to find the slope of this line. What we do is we take the y coordinate of the second point, subtract it from the y coordinate of the first point, and then we take the x coordinate of the same point, So for whatever you choose for your first y does not matter. For your second x, you must select the same one from that y. So this would have to be a 5, and this has to be a 1. So we get 4 over 4, which means our slope is equal to 1. And this number here represents the slope. And to show this works both ways, if we chose this as y2 and x2, we would have 2 minus 6 over 1 minus 5, which is still equal to 4 divided by 4, just negative, which is still equal to 1. So this is one of the 3 big ways to represent 2 variable equations. This is slope, intercept, which is expressed in y equals mx plus b. So this y doesn't change, and it's always y by itself. You can never have, it's never 2y. If you have 2y, you divide by 2 to make sure it's y. So in slope intercept, it's always y by itself equal to the slope times x plus b. What b represents is just the y-intercept. When we draw a graph, we know there's an x-axis and a y-axis. What b is, this point has an x-axis of 0 and b. B is the point where the line crosses the y-axis. So when x equals 0, y equals b. So using this equation, we have b is 5. Because when x equals 0, y equals 5. So that's one of the ways to represent lines. That's the second one. Slope-intercept form. This is where you would take, so we're not always going to get such nice points like the x-intercept. But we usually want the equation in this form because it's very easy to work with. What slope-intercept form is, it says y minus y1 is equal to m times x minus x1. So what slope-intercept form is good at is giving you the equation when you have 2 points or 1 point in the slope, but we're not given an intercept. This is the one you're going to find most commonly. This is, oh wait, this shouldn't, I wrote the same name. This is point slope. My bad. Point slope form. That one's slope intercept. So say if we had the 2 points, 2, 6 and 5, 3. We have 2 points, so we need to find the slope between these 2 points. So what you need to use this form is slope So that's what you need to use this form. This form, we need slope So if you have 2 points or a slope with 1 point, you can always use this to find the equation. So we have 2 points here, which means this works. So what we would do is we'd first find the slope, y2 and y1. So we subtract. So this is x2 minus x1. So this is our, and we have our slope of -1. So we have our slope. So our m is equal to -1. Now we can choose any point. Let's just say we choose this point. So now we have our y1 and x1. So now we have the 3 unknowns. We can plug it in. So we have y minus y1, which is 6, equals m, which is -1, times x minus 2. So that's y minus 6 equals -x plus 2. And let's isolate the y. If you ever have the chance, you want y by itself. So this is our equation using the point slope form. And there's one last form. This one's called standard. I don't think I spelled that right. You use standard form, usually in word problems, which is in the form of ax plus by equals c. It's like, say if like apples cost $5 and bananas cost $4, and we have $25, how many ways can we buy it? This is where this form is used most commonly. But when we have ax plus by equals c, we want to rearrange it. So again, y is alone. So we'd have subtract both sides by ax. So we'd have by equals c minus ax. And then we want y alone. So we just have y equals c minus ax over b. That's how you convert it. So something in standard form would be like 5x plus 2y equals 7. And then we can convert it to this. So we have our c. So we have y equals 7. Okay, let's take a look at our a, which is 5. And let's use our b, which is 2. So we have this as our equation. We want to convert it to slope-intercept, which is 7 halves minus 5 halves x. And that, I'll put it here, is equal to y equals negative 5 halves x plus 7 halves. So now we converted that to slope-intercept. You guys good with that concept? No, all these forms aren't used to find the slope. This is used to find the equation of a line. So let me write these down. So this is going to be like a little cheat sheet. So slope. This is how you find slope. So this is a slope formula where m is the slope. M stands for slope. And these are just the coordinates of points. And now we have slope-intercept. Which is and the m is equal to the slope. The b is equal to the y-intercept. And now we have the third form, which is point slope, which comes in the form of y minus y1 and we use this when we have the slope plus the y-intercept. We use point slope when we have 2 points or 1 point and the slope. And then for the last one, which is standard, oh wait, I wrote that wrong. Y is equal to c minus ax. And we use this for word problems most commonly. So we have these. So this is like calculating slope. We use the y equals mx. This is slope intercept. Slope, we have slope is equal to the y coordinate of a point minus the x, the second point minus the first point, and the x coordinate, the second point minus the first point. And then these are the formulas. So now that we have the formulas down and how to find it, let's start with how to graph them now. So say we have a graph. Let's start with how to graph with slope intercept. I forgot my graph paper, so that it's going to look sloppy. So what we do, say if we're given an equation, what you first do is you look at this b term, and then you go on the y-axis and you find b. In this case, it would be 0, 5. And you go to this point, and then you use a 2x. So now we plug in values. When given these, you always want to plug in x equals -1, 0, and 1. Those are the easiest to calculate. So when x equals 0, it's 0, 5. When x equals 1, you get 7. So we have 1, 7. Now when x equals to -1, we have -2 plus 5, which is 3. So we have -1 here. We have -1, 3. And now we'd connect these over ruler. We'd extend it. And that would be our line. This is for standard. We would so our first step is and then we go to the second step. Try to straighten that out a bit. That was the wrong way. Okay. And now the second step is and then the final one is we connect the points. When given something in point slope, so this is when you do standard. So now we know how to convert to standard. When given, if you give an equation in point slope form, you don't actually have to go to the y-axis. Let's say we have y minus 2 is equal to 5 times x minus 1. We already have a point and we have a slope. So we know one point that exists on this graph is 1, 2 using this and this. So we get 1, 2 from this. So we take our graph, we find 1, 2, and then we test the points 1 greater and 1 less. So 1 greater, which would be x equals 2, we can plug it in. So 5 times 1 equals 5. Y is equal to, so we have y minus 2 equals 5. So we get y equals 7. We get 1, 2 and 2, 7. Now we test 1 less, x equals 0. So we have -5 plus 2, which is -3. So we get 0, -3. We connect the points, and that's our line. So for this, we'd find the point used. Then our second step would be to test Oh, you guys are saying it's slightly blurry. I'll try to bring it a bit closer. The focus isn't very good. Let's try to write slightly larger. But now we have this. And now in our last form, we have standard form. So this is the standard for point slope. So this is slope. So this is what we want to use most commonly because that one's the easiest. But we also have the last one, standard form. Let's say we're given 2x plus 3y equals 6. What's actually easiest for this is just step 1. And then just use and then we use just slope intercept to graph. So that's how we want to graph a standard form. So are there any questions about how to graph and how the forms work? So we have these big things. We have how to graph the forms. We have, and also how each form works. So this is very important. If there are no more questions, we can take a quick 10-minute break before we learn about how to graph inequalities. These two variable inequalities on a graph. Okay, let's come back at 6:30. Okay, so it's been about 10 minutes. So let's just come back, and I got a few simple practice problems. So for the first one, so you want to find the slope between 5, 2 and 7, 8. And then you don't need to send me the graph, but I want you guys to try graphing. And the last one is convert I want you to convert 2x plus 5y equals 10 to slope intercept. And I don't know if I can fit this, but the formula sheets are right here. The first one. It's probably the one you'll need the most. And the second one, if anyone needs it, just ask and I'll show it for how to graph. I'll give you guys about like 7 minutes. This is a slightly longer problem set. And remember not to miss any negative signs. Okay, so let's start with these. So for the first one, we take y2, which is this, minus y1 over x2 minus x1. So we get that is equal to 3. So we have the slope is 3 for the first one. Now for the second one, for the graph, we have, this is in slope intercept form. So we know 0, 1 is a point. When x is equal to 1, we have 3 plus 1. So we have 1, 4. And then x equals -1, we have -2. So -1, -2. Line straight through these 3 points, and that's the graph. And then to convert to slope intercept form, we want to isolate the y, so we have 5y equals 10 minus 2x. We divide by 5 to get y is equal to 2 minus 2/5 x. So y is equal to -2/5 x plus 2. Those are those problems. And finally, let's talk about inequalities. So we already went over when we have this, but now we can do, so when given this, so the steps you want to take are 1, you want to convert. So use all the formulas from before. This class is to 7 o'clock. So today's class will end at 7. So first we want to convert this to slope intercept. And now we take the second step. So converting the slope intercept, we use the exact same techniques we've used before. And the only difference is if we're multiplying by a negative number, we need to remember to flip the signs. And now 2, check if there, so this is where we have 2 cases. When it's this or this, instead of drawing a solid line in our graph, we actually draw a dashed line. But if we have this or this, it's a solid line. So this is dashed, and this is solid. And now, step 3. Graph the equation, and then using the correct line. So in this case, we have 0, 3. We have a slope of 2. It's poorly drawn. Oh wait, there should be an equals. So solid line for this. And now we have to use a test point. So we can see 0, we want to find any point that's not on the line. A very easy one is 0, 0. And now I want to test. We plug in 0, 0. So y equals 0, which is less than or equal to 0 plus 3. This equation is true, which means 0, 0 is in the side of the line, which is true, which means everything on this line, this side of the line, satisfies the equation. So we would shade this, and this area is the solution area. And now say if we remove this, we just draw a dashed line down this entire thing, and it'd be the same. So it's done the exact same as the other graphed lines, except the only difference is we use dashes. And if say 0, 0 wasn't correct, say it was this way, and 0, 0 was wrong, because we have 0 is not greater than or equal to 3, we would shade the other side of the line, which would be over here. So that's pretty much it for all the graphing. Let's move on to the last portion of today's lesson, which is going to be word problems and applications. So let's say a very easy one. Hats cost $3 each, and shoes cost $4 each. We have, let's say we have $20. So we want to set this up. And now we have so try this. Try using inequalities to solve this. Using what we've learned today, and I'll give you guys let's say 5-10 minutes to solve this. This can be the last question of the day, and I'm going to let you guys out a bit early because I have to go to something at 7 o'clock today.
I have a question.
Yes.
Do each shoe cost $44, or does the pair of shoes cost $4?
The pair of shoes cost $4.
Okay.
So when we're referring to shoes, it's like a box of shoes. So actually, in fact, almost everyone got that one. So we can see a very easy application. Let's call hats are X and shoes are Y. like I said, this is a word problem, so we can use the standard form equation that we've been talking about. Call 3x. The 3 is because each hat is worth $3, plus 4 because each pair of shoes is worth $4, and then we have $20. So we must spend less than or equal to $20. And now we know we have one hat. So x equals 1. So we have 3. So we have 4y is less than or equal to 17. But we can't buy like a half a shoe or a quarter of a shoe. So only discrete values work. But we also can't buy a negative number of shoes. So the only values of y that work are 0, 1, 2, 3, or 4. So if your answer was any of these 5 numbers, it's correct. We can buy anywhere from 0 to 4 pairs of shoes. So I'm going to give the last 5 minutes to any questions you guys have over today. I know today was a pretty difficult class. This is going to be the hardest class of the entire course. And most of next week's class is going to be reviewing and reteaching today's. We're going to go back over graphing after I see the homework, and we're just going to try to get that down. So I know today was probably very confusing, but we're going to go over again next week so I can see where the issues are with the homework, and we're going to try to work this through. And all the other future topics are going to be a lot easier. And there's going to be, this is probably the end of all the algebra we're doing after next week. So yep, I have nothing else for you guys today. Have a great day. And I guess I'll see you next week. If you have any questions, I'm going to stay here for a little bit more. But otherwise, you're free to go.
Bye. I have a question. Can you like scan the sheet that you put all the graphs on and send it to Google Classroom?
Oh yeah, sure. Actually, what I was going to do is later this week when I have time,
Thank you.
probably in a few days, I was going to write them all down in a Google Docs, all the formulas and all the steps, and I'll send it to you guys.
Okay.
Bye, thank you.
Thanks.
No problem. See you guys.